Here in this section we have trigonometric integrals, products of power of sines and cosine. So what we have here is integral of sine power is m times cosine power is n times dx. M and n are non-negative integers, but that means m and n are positive or zero. We can divide the appropriate substitution into three cases according to what we have for m and n, if m and n are odd or even. Case 1 is when m is odd. We write m as 2k plus 1 and use the identity sine squared equal to 1 minus cosine squared. So using that, when we have sine power m, that is equal to, so instead of m, we have 2k plus 1, and that is equal to sine 2k is over power multiplied by sine. So here power is 2 times k, and here power is 1. We have multiplication, but that means adding powers. So we have same base. So adding powers, we have 2 times k plus 1, and that is over m, equal to, instead of sine squared, we can use 1 minus cosine squared. And here outside we have this power k multiplied by sine x. Then we combine the single sign with dx in the integral and set sine x dx equal to negative d cosine x. Case 2, if n is odd, in integral sine power m times cosine power n times dx, we write n as 2k plus 1 and use the identity cosine squared equal to 1 minus sine squared. To obtain cosine to the n power equal to, instead of n, use 2k plus 1. So we have cosine power is 2k plus 1, and that is equal to cosine 2k. So it's called cosine squared. And here outside we have power is k multiplied by cosine x equal to, instead of cosine squared, now use 1 minus sine squared, power is k multiplied by cosine x. We then combine the single cosine with dx and set cosine dx equal to d times sine x. Case 3, if both m and n are even, so both of powers are even, in integral sine to the n power multiplied by cosine to the n power multiplied by dx, we substitute sine squared equal to 1 minus cosine 2x divided by 2, and what we have for cosine squared, that is equal to 1 plus cosine 2x divided by 2. To reduce the integrand to 1 in lower powers of cosine 2x. Example, evaluate the integral cosine cube dx. So here first we have to start with factoring cosine cube, and that is equal to cosine squared times cosine. And then instead of cosine squared, we use 1 minus sine squared. So cosine cube is equal to 1 minus sine squared times cosine x, and then use distributive property. We have cosine times 1 minus cosine times sine squared. So cosine cube is equal to cosine x minus sine squared times cosine. So our integral is equal to integral of cosine minus sine squared cosine x times dx. That is equal to integral of first term, which is cosine, minus integral of second term, sine squared cosine. Based on what we have here, let u equal to sine and du is equal to cosine x times dx. So derivative of sine is cosine. So now instead of sine squared, we have u squared and cosine x dx, that is du. So derivative of sine is cosine. That means that the integral of cosine is sine minus integral of u squared. Here power is 2, so add 1. We're going to have 3 for our power and use that here in denominator. So what we're going to have, it's 1 divided by 3 u to the third power plus constant. So using c for constant. And then this is equal to sine x minus 1 over 3. Instead of u, we have to use sine x. Power is 3, so it's sine cube, then plus c. So this is our final answer. Evaluate the integral for cosine cube 7x times dx. The given integral is of the form integral sine to the n power times cosine to the n power times dx, where m is 0, because here on this part we don't see sine. That means power for sine is 0. So m is 0 and n is odd. So n is what we have here, and that is 3, so that is odd. So here on this part we're going to use 2k plus 1 instead for n, and cosine squared is equal to 1 minus sine squared. So our integral is equal to integral 4 times cosine instead of 3. So for our power we have to use 2k plus 1, and what we have for power is 3, so that means k is 1. So 2 times 1 plus 1, this part is 3, and then what we have here 7x times dx. So moving 4 outside of integral, we have 4 times integral cosine squared 7x times cosine, here is power 1. So when we have 2 plus 1 power 3. So we have cosine squared times cosine times dx, but here we have, instead of x we have 7x. And then instead of cosine squared we have to use 1 minus sine squared. It doesn't matter what we have for that part. So cosine squared 7x is 1 minus sine squared 7x multiplied by cosine 7x times dx. Note that 7 cosine 7x dx, that is equal to derivative of sine 7x. So what I use here for u is equal to sine 7x, and derivative of u is so what we have here, coefficient of x is 7. Move that one to left side, so you have this 7 first, and then derivative of sine is cosine, and then we write what we have here after sine. So we have 7 times cosine 7x, and then I divided both sides by 7 because wanted to see what I have to use for cosine 7x. So du divided by 7 and 7 cosine 7x divided by 7. So what we're going to have for cosine 7x is du divided by 7. So our integral is equal to 4 times integral 1 minus, instead of sine squared I used u squared multiply cosine 7x, that is du divided by 7. And then I'm going to move 4 divided by 7. So we already have 4 outside of integral, but I'm going to move 1 over 7 outside of the integral. And I will have 4 over 7 here first, and then integral, rewriting this part, 1 minus u squared du, and this is equal to 4 over 7. Here we have 1. So this is u. So this 1 means we have u power 0, 0 plus 1 power is 1, and then divided by 1. but instead of writing u divided by 1, here I have u. Then minus, here we have u squared. So adding 1 to our power, we're going to have 2 plus 1. So that is 3. And then divide by same number. So we're going to have 1 over 3 u cubed plus constant c. And finally, instead of u, so what we had here was sine 7x. So use that one here. And then minus sine cube 7x divided by 3 plus constant. So our final answer is equal to 4 over 7 times sine 7x minus sine cube 7x divided by 3 plus constant. Evaluate the integral 7 sine cube 2x cosine cube 2x times dx. So what we have here on the spot is using integral sine to the n power times cosine to the n power times dx, and in this case m is odd. We're going to use m as 2k plus 1, so what we're going to use for m is 2k plus 1, and then use sine squared equal to 1 minus cosine squared. This is equal to integral 7 sine. So instead of 3 we have 2 times 1 plus 1 over k is 1. Then 2x times cosine cube 2x times dx. Then move 7 outside of integral, and what we're going to have is sine squared times cosine cube times sine times dx. And for all of these we have 2x. Next step, instead of sine squared, use 1 minus cosine squared. So this is equal to 7 times integral 1 minus cosine squared 2x times cosine cube 2x times sine 2x multiplied by dx. Note that the derivative of cosine 2x is equal to negative 2 times sine 2x. So derivative of cosine is negative sine, but here we have 2. So we have to use coefficient of x, which is 2, and then move that outside. That is 2 times derivative of cosine is negative sine, and then write what you have after cosine here on the spot. So this is equal to negative 2 sine 2x, let u equal to cosine 2x, and derivative of u is equal to negative 2 sine 2x. And then we want to see what we have for sine 2x, because here we have sine 2x. So isolate sine 2x, divide both sides by negative 2. This means sine 2x is equal to du divided by negative 2, or I can write negative 1 over 2 times du. And that is equal to sine 2x. So instead of cosine 2x, I used u. And instead of sine 2x, I used du divided by negative 2, or negative 1 over 2 times du. And this is equal to 7 divided by 2. So I move this part outside of integral. So this is equal to 7 over 2 integral negative times, because of this negative here on this part. So negative times 1 minus u squared times u cubed du. So I use distributive property, u cubed times 1, u cubed times negative u squared. So this is equal to 7 over 2 times integral minus u cubed minus u to the 5th power times du. Then multiply this negative, we're going to have negative u cubed plus u to the 5th power. So I'm writing u to the 5th power first, and then minus u cubed. So this is equal to 7 over 2 integral u to the 5th power minus u cubed times du. And this is equal to 7 over 2 times, here we have u to the 5th power. So integrate, we have 5 plus 1. 6 is our power divided by 6, so here 1 over 6 times u to the 6th power minus Then we have u cubed, so we're going to have 3 plus 1, that is 4. Divide by 4. So we have 1 over 4 u to the 4th power plus constant. Now instead of you use cosine to x, so what we had here on this part, our answer is 7 over 2 times 1 over 6 cosine to the 6th power 2x minus 1 over 4 cosine power is 4. Then here we have 2x plus our constant. So this is our final answer for this part. Evaluate the integral from pi to 3 pi divided by 2, 99 sine power is 8 times cosine cube times dx. Integral is in this form where m is even and n is odd. So here what we have, instead of cosine cube, I use cosine square times cosine. And then instead of cosine square, I use 1 minus sine square. Then combine the single cosine x with dx and set cosine dx equal to d sine x. Let u equal to sine x. So derivative of sine is cosine. What we're going to have is du equal to cosine x dx. So this is equal to integral 99. Instead of sine, I used u. So we have u to the 8th power times 1 minus u squared times du. And then I used distributive property. So 99 u to the 8th power times 1, 99 u to the 8th power times negative u squared. So this is what we have here on this part, and then that is equal to, so here integrate u to the 8th power, we have 8 plus 1, so our power is 9, and then divide by 9. So we have 99 divided by 9, multiplied by u power 9 minus, now second term, here on this part we have u to the 10th power, so 10 plus 1 is 11, and then divide by same number. So what we're going to have is minus 99 divided by 11 times u to the 11th power plus constant, so use c, and then simplify. So 99 divided by 9 is 11, and 99 divided by 11 is 9, so this is equal to 11 u to the 9th power minus 9 u power is 11 plus c, and then instead of u we're going to use sine. So here what we have is sine power 9, and here sine power is 11. So this is equal to 11 sine power 9 minus 9 times sine power 11 plus c. Our integral was from pi to 3 pi over 2, so use pi and 3 pi over 2 instead of x. First using 3 pi over 2, and then subtract and use pi instead of x. So we have 11 sine to the 9 power. Here we have 3 pi over 2 minus 9 sine to the 11 power. Again, here instead of x we have 3 pi over 2 minus 11 sine to the 9 power. X is pi minus 9 sine to the 11 power. X is pi. Sine 3 pi over 2 is negative 1, and sine pi is 0. So what we're going to have is 11 times negative 1 minus 9 times negative 1 minus 11 times 0 minus 9 times 0. So this part is 0, and what we have for this part is negative 11 plus 9. So our answer is negative 2. So this is our final answer. Evaluate the integral from 0 to pi over 14. 21 times square root of 1 plus cosine 14x times dx. Here on this part, to remove this radical sign, rewrite the integrand using a half angle identity. So this is half angle. identity, and then based on that, our integral is equal to 21 times square root of 2 times cosine 14x divided by 2 times dx. So what we had here for half angle cosine x over 2 is equal to negative positive square root of 1 plus cosine x over 2, but what we have here in this case, instead of x, we have 14x. So I simplified this part because based on what we have here, we have square root of 1 plus cosine 14x, and on this part we have square root of 1 plus cosine x divided by 2. So I multiply both sides by square root of 2 to be able to find square root of 1 plus cosine x, which is same as what we have here on this part, but the only difference, after cosine we have x, but here we have 14x. So square root of 1 plus cosine x, that is equal to square root of 2 times cosine x over 2. Again, here we have 14x instead of x, so what you're going to have is 14x divided by 2 instead of what I have here. So instead of a square root of 1 plus cosine of 14x, we have square root of 2 times cosine 14x divided by 2, and then multiply by dx. So that is equal to, I moved this part outside of integral and rewriting what we have after integral. And then this is equal to 21 times square root of 2. Integrate this part, that is 1 over 7 sine 7x, and this is from 0 to pi over 14. So now use pi over 14 instead of x, and then use 0 instead of x. So what you're going to have is 21 square root of 2 times 1 over 7 sine, I simplify this part, so that is pi over 2, and this part here we have 7 times 0, so that is 0, sine 0 is 0, so this part is 0, and I didn't write that part again. So what we have is 21 square root of 2 times 1 over 7 sine pi over 2 is 1. And then simplify, so we have 21 divided by 7 times square root of 2, and the final answer is 3 times square root of 2. Divide the integral secant square 2x times tangent power is 7. Here again we have 2x times dx. We call that derivative of tangent is equal to secant square. Let u equal to tangent 2x, so derivative of u is equal to 2 secant square 2x dx. Here on this part we have secant square 2x dx, and that is equal to du over 2. So what I did, I divided both sides by 2, so that way I can find what I can use instead of what we have here on this part. So that is 1 over 2 times du. Our integral is equal to integral u to the 7th power is what we have here, multiplied by 1 over 2 times du. I moved 1 over 2 outside of integral, so we have 1 over 2 integral u to the 7th power times du. Integrate, and this is equal to 1 over 2 times 1 over 8 times u to the 8th power plus constant. Now instead of u, use tangent 2x. So 1 over 2 times 1 over 8 times tangent power is 8, 2x plus c. So here 1 over 2 times 1 over 8, and that is 1 divided by 16. Tangent power 8, here we have 2x plus c for constant. So this is our final answer for this part.